All right, today we are working on Unit I in our SPILE review, and what is unique about Unit I is that there are no yellow pages, and it's kind of a long white pages. So really I'm just going to divide it up where I'll do some in your notes with you right now, and the ones that are not highlighted will become your homework, and then you will still take pictures of all 5 pages to upload for me. So topic 1, number 1 is the first one I'm going to do with you. I'm going to do any that I've dotted with highlighter here, which is really one of each kind as we go along. So Unit I and Unit H are very closely related. Unit H was all about factoring. We're just going to take that factoring one step further to solve the equation, meaning we're finding the zeros of that equation. So for number 1, I'm going to start by pulling out my greatest common factor, which is in this case is just n. So then I'll have 3 plus n equals 0. And then using the zero product property, we know that if I set each individual piece equal to 0, that's how these could be multiplied back to 0, since 0 times anything else is 0. So if n is equal to 0, then that's all you have to do. 3 plus n equal to 0 would make n negative 3. Or if you like to think of it as 3 plus negative 3 would make this piece 0, this piece was already 0. All right? That's how we're taking it one step farther to just identify what n could be equal to for the whole thing to be equal to 0. So I'm going to do number 1 on topic 2 now. I'm going to start by factoring. So factors of 16 that add to 10 would be 8 and 2. And then for each piece to be equal to 0, p would be negative 8 to make this piece 0. And p would be negative 2 to make this piece 0. So p could be negative 8 or negative 2. Typically, you have as many solutions as you have your largest exponent. Since these are quadratics, their largest exponent is 2, typically we will have 2 answers. If I had an exponent of 3, I could have 3 answers. Linear equations with just an exponent of 1 have 1 answer, and so on. All right, so that's it that I'm working on page 1 with you. On page 2, I'm going to do topic 4, number 1. So it's a solve each equation by factoring again. This one, I'm going to pull a 6 out first. My greatest common factor for this one is 6. So let's see. That'd be 14. And then factors that multiply to be negative 14 and add to 5 would be positive 7 and negative 2. And then there's no variable on the outside here, so don't worry about that piece. This piece to be 0 would be negative 7. This piece to make 0, I would need a 2. Topic 6, number 1, this time I have a difference of 2 perfect squares. So to factor that, I'm going to have x minus 2 and x plus 2 equals 0, because 2 is the square root of 4 and x is the square root of x squared. If I were to FOIL this back out, double distribute, use the box method, whatever your preference is, I would end up having no middle term. So you can also think of it as what multiplies to negative 4 but adds to 0, since there's no middle term, which would be negative 2 and 2. So in this case, I would have positive 2 for this piece, negative 2 for this piece. Moving on to our third page. I'm going to start at topic 9. Problem 1, this one says solve each by factoring, but it's not equal to 0 yet on the right-hand side, so I need to make it equal to 0 on the right-hand side before I can factor. So I'll add 6 to both sides. And now I can factor. I'll need the box method for this one, since I have my leading coefficient is larger than 1. So I need factors that multiply to 42 and add to 17. And I got 42 by taking 7 times 6. So let's see what we can come up with here. Looks like 3 and 14. So I'll have 3a and 14a here. And then I'm going to pull out a GCF. So this would just be A. This would be 2. This would be 3 and 7A. So I'll have 7A plus 3 times A plus 2 equals 0, which is going to make A negative 3/7 if I were to set this equal to 0 and solve, and negative 2 for this piece. On our 4th page, let's take a look at topic 10, number 1. It's the same idea where I'm going to have to move things around before I can factor. So I'm going to add 8x squared to both sides. That's going to give me 1x squared, which is nice. I like to have a leading coefficient of 1 if I can help it. And then I will still have to subtract 5x. So factors that multiply to 20 and add to 9 would be 5 and 4, which is going to make x equal to negative 5 and negative 4. All right, solve by taking square roots. This method only works if you do not have a middle term. In this case, we don't have a b term. We just have b squared and a constant. But I can solve by square roots by just solving for b, essentially. So I'm going to start by subtracting 1 from both sides. That's 64, and then I'll divide by 81 on both sides. B squared equals 64 over 81, and then to get rid of that squared, I will square root both sides. B is equal to positive or negative 8/9. Okay, you need the plus or minus. Again, every time you have an exponent of 2, you should have 2 solutions. So our solutions are positive 8/9 and negative 8/9. Right, so that would be this section. And then the last method we are using today is the quadratic formula. So if you remember back in algebra, we had the quadratic formula. You might have heard some songs like to the tune of Row, Row, Row Your Boat or Frere Jacques, but it's x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And this is when you have ax squared plus bx plus c. Okay, this is your standard form equal to 0. Okay, so for 13, number 1, I'm going to start by making it equal to 0 by subtracting that 12b. So I'm going to have 5b squared minus 12b minus 9 equals 0. And now I know my a is 5, my b is negative 12, and my c is negative 9. So if I use my quadratic formula, I will have 12 plus or minus the square root negative 12 squared minus 4 times 5 times negative 9 all over 2 times 5. All right, so if I have 144 underneath my square root, I am going to have, hold on, $324, and the square root of that is 18. So it's really 12 plus or minus 18 over 10. And they don't always come out to be perfect squares. A lot of times they're decimals. So 12 plus 18 is 30. 30 over 10 is 3. 12 minus 18 is negative 6. Negative 6/10 is negative 3/5. Okay, so those would be my 2 solutions there. Okay, you should still have 2 solutions when you have an exponent of 2. All right, so that's the last one I'm going to do with you. The ones that I did not do with you have now become your assignment. And when you finish that, you can take a picture of them and upload them to Canvas.